Good day, students. How are you? Now go to the topic named the probability of falling of the continuous random variable with the normal distributive density into the symmetric interval. Therefore, first give the definition of a symmetric interval. The interval of type A minus L, A plus L is named the symmetric interval. Here A is symmetric center and L is the radius of this symmetric interval. And geometrically the symmetric interval is represented in the following form. It is A, symmetric center, and here A minus L, and here A plus L is situated. And here A is the symmetry center, and it is radius L. This distance is equal to L. L is radius of symmetric interval. Already you know the formula of probability of falling of the continuous random variable with the normal distributive density into the interval alpha beta. And this probability is expressed by means of error integral in the following form. P that continuous random variable x is situated between alpha and beta is equal to 1 second multiplied by phi capital of beta minus a over sigma square root of 2 minus phi capital of alpha minus a over sigma square root of 2. This formula already is known for you, and then let substitute a minus l instead of alpha and a plus l instead of beta. Let alpha is a minus l and beta is a plus l. Substitute instead of beta and alpha, then we will have p of a minus l is less than x is less than a plus l equals 1 second multiplied by phi capital a plus l minus a over sigma square root of 2 minus phi capital a minus l minus a over sigma square root of 2. Here a and minus l will be deleted, removed. Then we will have equals 1 second multiplied by phi of L over sigma square root of 2 minus phi of minus L over sigma square root of 2. But you know that the error integral phi is odd function, and therefore we can take negative sign out of the error integral symbol. Then we will have 1 second multiplied by phi of L over sigma square root of 2 plus phi of L over sigma square root of 2. Then 1 second multiplied by twice twice, because this expression are identical, are the same. 2 twice phi of L over sigma square root of 2. Here 1 second and 2 are simplified, and finally we will have phi of L over sigma square root of 2. You see that here in this formula, in the argument of the error integral, the parameter A is absent. And it means that the considered probability doesn't depend on A, doesn't depend on symmetry center. And finally we obtained the following formula of probability that the continuous random variable with a normal distributive density will fall into the symmetric interval. And here it is P that A minus L is less than X is less than A plus L is equal phi of L over sigma square root of 2. It is final formula of our topic. Thus, we obtained the following result: the probability that the continuous random variable, the continuous random variable with the normal distributive density, normal distributive density will be situated in the symmetric interval, Already you know this topic and its final formula. Probability that continuous random variable x will be situated between A minus L and A plus L is equal to phi capital of L over sigma square root of 2, which is very important formula. And now we can go to the new topic named the 3 sigmas. The 3 sigmas. 3 sigmas. Sigmas. 3 sigmas. Or 3 sigmas. 3 sigma. Here, sigma is standard deviation. Standard deviation, or the mean quadratic deviation, also standard deviation. Let L is equal to 3 sigma. Let L is equal to 3 sigma. then substitute 3 sigma instead of A. Then we will have P capital A minus 3 sigma is less than X is less than A plus 3 sigma is equal to phi of 3 sigma over sigma square root of 2. Here we can simplify this fraction by sigma, then we will have phi of 3 over square root of 2 approximately is equal to, you know that the square root of 2 is approximately equal to 1.4. Phi of 3 over 1.4 approximately equal to phi capital of 2.1. And according to the table of error integral values, it is approximately is equal to 0.99, and also it is approximately is unit. It means the falling the continuous random variable into the interval a minus 3 sigma, a plus 3 sigma is a certain event because its probability is unit. It means the continuous random variable with the normal distributed density always will be always can be situated in the interval a minus 3 sigma and a plus 3 sigma. This fact is named is called the 3 sigmas rule. 3 sigmas rule. The next topic is named the Laplace function. Laplace function. And the expression of this function has the following form. And Laplace function is denoted as phi capital bar of x is equal to 1 over square root of 2 pi multiplied by integral from 0 to x of e to minus t squared in half dt. It is Laplace function. And then we must then define the connection of Laplace function with the error integral and express Laplace function by means of error integral, and also express the error integral by means of the Laplace function. Rewrite Laplace function in the following form: equals 1 over square root of 2 pi multiplied by integral from 0 to x of e to t over square root of 2 squared dt. Then introduce the following change. Let t over square root of 2 is z, new variable z. Right, change. Use the following change. Let z is z z is t over square root of 2. Then from here t is z multiplied by square root of 2. Then find dt is square root of 2 dz. And also we must we must consider the integral limits, because these integral limits 0 and x are the integral limits of the integral variable t. But we must obtain the corresponding integral limits for new variable z. If t is 0, then substitute 0 instead of t, 0 over square root of 2 is 0. Z also is 0. But if t is x, it is upper integral limit, t is x, then substitute x instead of t, and then we will obtain z equals x over square root of 2. And change and apply this change to this interval, to this interval. 1 over square root of 2 pi all by integral from 0 to x over square root of 2 of e to minus z squared multiplied by square root of 2 dz equals. Then here square root of 2 is the constant factor which can be taken out of the integral symbol. Then we will have square root of 2 over square root of 2 pi all by integral from 0 to x over square root of 2 of e to minus z squared dz. Here we can simplify the coefficient by square root of 2. And then we will have only 1 over square root of pi multiplied by integral from 0 to x over square root of 2 of e to minus z squared dz. Then remember the formula of the error integral. Remember error integral. Continue. Now remember error integral. Error integral is phi, simply phi of x is equal to 2 over square root of pi multiplied by integral from 0 to x of e to minus t squared dt. This is error integral. And use this formula for expressing the Laplace function by means of error integral. Continue. Then continue. Also, you know that the value of the definite integral doesn't depend on integral variable, and therefore we can change t by z here. Then you can rewrite the error integral phi of x, because error integral depends on only x, but doesn't depend on the integral variable. 2 over square root of pi multiplied by integral from 0 to x of e to minus z squared dz. Continue. Here multiply and divide the coefficient by 2. Then we can write 1 second, multiply by 2 over square root of pi, multiply integral from 0 to x over square root of 2 of e2 minus z squared dz equals, continue. This expression in parentheses is the value, is the expression of R integral at the point x over square root of 2. Because here we have x, but here x over square root of 2. It is equal to 1 second multiplied by phi of x over square root of 2. Thus we obtained the expressing the Laplace function by means of error integral. That is phi capital bar of x is equal to 1 second multiplied by phi of x over square root of 2. But also we can express R integral by means of Laplace function. And for this define the expression of Laplace function at point x multiplied x square root of 2. That is, substitute x multiplied by square root of 2 instead of x. Phi capital bar of x square root of 2 is equal to 1 second multiplied by phi of x square root of 2 over square root of 2. Then square root of 2 we can simplify by square root of 2, and therefore we will have, it is 1 second multiplied by phi of x. And we can obtain expression, we can obtain phi of x from this formula. Therefore phi x is equal to 2 multiplied by phi capital bar of x square root of 2. It is expressing the R integral by means of Laplace function. Further express the probability that the continuous random variable with the normal distributive density will be situated in the interval alpha beta by means of Laplace function. The expressing of the probability that the continuous random variable with normal distributive density, will be situated in the given interval, interval by means of Laplace function. By means of the Laplace function. Laplace function. Remember the formula of probability that continuous random variable will belong to the given interval by means of error integral. Error integral. See that x will be situated between alpha and beta. Remember this formula, which is 1 second, 1 second, 1 second multiply phi of alpha beta minus a over sigma square root of 2 minus phi of alpha minus a over sigma square root of 2. Already you know this formula and suppose that here a is 0, and let a is equal to 0 and sigma is equal to 1. I want to simplify this formula. P that alpha is less than x is less than beta equals 1 second multiplied by phi capital of beta over square root of 2 minus phi capital of alpha over square root of 2. Further, remember the expressing the error integral by means of Laplace function. It is the following function, is the following formula. Phi of x is 2 multiplied by phi capital bar of x multiplied by square root of 2. Remember this form, use this formula, continue. Here first substitute beta over square root of 2 instead of x, and then substitute alpha over square root of 2 instead of x. 1 second. 1 second. Multiplied by 2 multiplied by phi bar of substitute beta over square root of 2 multiplied by square root of 2 minus 2 multiplied by phi capital bar of alpha over square root of 2 multiplied by square root of 2. Then we can simplify by square root of 2 and take 2 out of the bracket, as because here 2 is a common factor. 1 second multiply by 2 multiply by phi with the line phi bar of beta minus phi bar of alpha. Then simplify 2 and 2, and finally we obtain the very important result. that P of alpha is less than x is less than beta is equal to simply phi bar of beta minus phi bar of alpha. It is very important formula. It is increment of Laplace function, and it means the probability that continuous random variable with a normal distributive density will belong to the given interval alpha beta is a increment of Laplace function, that is the difference of Laplace function values at endpoints of the given interval. Our lesson ended. Dear students, good luck. Goodbye, students.